Okay, so now we're going to start talking about a continuous probability distribution, which is what it says at the bottom of the agent, bottom of the page. And the big key understanding here is that you can find any probabilities in this region by finding the area of the region. Well, why is that? Well, it goes like this. It's very important for you to understand that each of these events from 0 to 20 are equally likely. That's why on f of x, which is the frequency of them, as you look across, you see that it stays the same. If it in any way, shape, or form fluctuated or bent, then the probabilities wouldn't be the same. But because that bar is at the same exact height, the probabilities do stay the same. Now, how many scores are there here? There's 0 to 20, so there's 20 total scores. And because each one has the same probability, each probability has to be 1/20th. So what I want you to notice here is that this probability, 1/20th, goes here, which is 1/20th. And the reason it's 1/20th is because you go from 0 to 20. Remember, in a probability distribution, a discrete one, okay, all the probabilities have to add up to 1. And in this case, if there's 20 different events and all the probabilities are going to be the same as indicated by this flat level line which shows the frequencies, then that means since there's 20 probabilities, they've each got to be 1/20th. All right? So that's why the key understanding here, that the probability of any event X is 1/20th for every single score all the way across here. Okay? So that's why it's a horizontal line segment. And if you check it out, if we figure out the area here, area of any rectangle is always the length times the width. So the length is 20 and the width is 1/20th. And if I do 20 times 1/20th, the area down here, I get 1. So this area, when you do this event, you either have to get a 0, a 1, a 2, a 3, a 4, all the way up to 20, or any score in between. When you compute that area, the sum of all the possibilities is 1, and each individual probability is between 0 and 1. So what that tells you is that this is a discrete probability distribution, and that makes things workable in terms of what it is we're going to figure out. The big conclusion here, the big reveal, if you will, is that if I want to find the probability of a piece of this rectangle, I just find the area of that piece and bam, I've got my result. Okay? So with that understanding in mind, let's take it to the next level and try to understand better. But that's a foundational understanding. Again, continuous probability distribution, the probability is the area. So suppose we want to find the area between 0 and 2. Same exact graph. The probability of x, f of x, is 1/20th. I want to find the probability of the area. I want to find the area between 0 and 2 because that will tell me the probability between 0 and 2. And that's what's really important. Notice what it says at the bottom of the page. The probability is the area. So if I ask the question, what's the probability that you're going to get something from 0 to 2? Well, if I figure out the area, I've got it. So the area is the length times the width. Now the width is 1/20th. That's not going to change. But the length is going from 0 to 2. So the way we find length is we do 2 minus 0. Okay? So that length, 2, multiplied by 1/20th makes 2/20ths, which if you take your handy dandy calculator and you do 2 divided by 20, you will get 0.1. So the probability that any result will be between 0 and 2 is 0.1. Notice that the height is the probability. It's 1/20th. Okay? Next up, suppose we want to find the probability that x is equal to 15 on the graph. On any x to y graph, x equals 15 is a vertical line. Keep in mind that a vertical line, this is open to a little bit of argument, but for all practical purposes, that vertical line has no width. okay, or a width of 0. So when we multiply, 0 times 1/20th is 0. So the probability of getting exactly a 15 is going to work out to be 0 because it's a vertical line. This type of problem is not used to figure out probability of a specific score, but it very much is if I want to calculate the probability between two variables, because that forms an area. And basically, we're going to make a, in this case, purple rectangle in the middle. So if I want to find the probability that a particular score comes between 2.3 and 12.7, all I have to do, I already know the height is 1/20th. That's not going to change, but I just got to figure out what the length of this rectangle is. And that's just going to be 12.7 minus 2.3. So I do 12.7 minus 2.3 on my handy dandy calculator. I can put it in parentheses or I can hit enter. It doesn't make a difference. And then I do times 1/20th. Quickest, easiest way to put that in on a graphing calculator is alpha y equals, and I get 0.52. So the answer is that the area between 2.3 and 12.7 is 0.52, and that means that the probability of an event happening that would result in a value between 2.3 and 12.7 is also 5.2 because the probability is equal to the area. I do apologize for subjecting you to my vocals. I was cut from a church choir. That is how bad my vocals are. Okay? So as we mentioned before, remember the height is the probability, and then the length is just going to be the difference between whatever two scores are marked on the rectangle. In this case, 12.7 minus 2.3. Okay, consider the function f of x equals 1/8 for scores from 0 to 8, right? That makes sense because they're going to be equal scores for that straight line that goes across the top. And there's 8 scores, so that makes the probability 1/8. So draw the graph of f of x and find the probability between 2.5 and 7.5. So I just want to go back. This is what they want you to do, or what I want you to do. We want you to do, whatever you want to say. We want you to draw this graph that's in the white background here. You don't need to write remember height equals probability, but we want you to mark the numbers along the side. In particular, you can mark over here. On the other graphs, we had marked 20. And also fill in whatever the width is here. And then find that area to find the probability that the score is between 2.5 and 7.5. I'll do a little stop and start here. Okay, so first I draw the picture. I know that my height is going to be, the height is the width, which is 1/8 right here. Okay, it's the width of the rectangle, but it looks like the height on the graph. And I mark, look, this graph goes from 0 to 8. And I'm going to mark the area from 2.5 to 7.5, and I'm going to draw that rectangle. Now, all I need to do is subtract 2.5 minus 7.5, which gives me 5. And then remember that this uniform height that goes all the way across, because all the scores are the same and it's continuous, is 1/8. So I recall, that's where I get the 1/8 from. And then area is length times width. So the 7.5 minus the 2.5 works out to be 5. And I multiply that by the width of the rectangle or the height of the graph, same thing, and I get 5/8. Okay. This area technique only works for when the probability is the same throughout. That is to say, it's continuous, it's uniform. If the probability can change, then you can't go sketching a rectangle because the probability that we mark on the side of the graph here would go up or down if it changes, and then the figure is no longer a rectangle. Okay? All right, key point there. Only works because that probability is the same throughout, that it is uniform. All right, so consider the function f of x is equal to 1/8 for from 0 to 8. Draw the graph of f of x and find the probability this time for 2.5 to 5.5. A chance for you to work that same type of work we did a moment ago. Okay, so we know that the height is going to be 1/8. I know that because I looked in what I was given over here and it says 1/8. So I insert that into my diagram. I know that the whole rectangle goes from 0 to 8, but I'm only concerned with the part that goes from 2.5 to 5.5. So I highlight that and I make the rectangle. Now the question is, what is the area of that rectangle? Well, it's going to be length times width, and the length is going to be 5.5 minus 2.5, which is 3 times 1/8. So altogether I get 3/8. So this is a really good introduction to the idea of uniform distribution. And remember that this technique only works with the probability staying the same 1/8 and being continuous through the area. If it's not uniform continuous, then you can't use this technique. But if it is, then you can draw the rectangle and you can find any probability that you're looking for. Okay? The uniform distribution, it only concerns events which are equally likely to occur. In other words, like the rectangle we drew with that horizontal line across the top. Okay, this will end the second video for today, and then we'll get into some more problems.